In this video, we are going to talk about the experimental procedure for Lab 3. The lab consists of 3 different parts. The first part is going to be a periodic table activity that can be found at the following address for all labs. The basic instructions for it is that you're going to go into the simulation, which I will do in a few moments, and then you're going to be clicking on the different components of the lab. And as you can see here, there's going to be questions that need to be answered on each one of the different components of the simulation. The questions specifically can be found on page 6, 7 of the lab sheet. When you go to all labs, as you can see here, the simulation, the address that is given in the lab sheet takes you directly to the modern periodic table simulation. In this process, as you can see, you are going to be clicking in the classification of the elements. So for example, I'm going to click first on the nonmetals and metalloids. As you can see, by clicking right there, then the dynamic periodic table that we see here are going to be labeling what are the nonmetal and the metalloids that are present specifically in the periodic table that they have. When it comes to the questions, for example, it says on page 6 that in this area you're going to list all the elements, the name and the symbol, that are considered metalloids. And as you can see, they're labeled in pink. We have boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. The second question in this area says list all the elements, name and symbol, that are considered nonmetals, and you're going to do that up to element 118. Now notice that in this periodic table you have symbols that are UUS and UUO. That is because that 3-letter symbol corresponds to the unknowns that used to be utilized before the permanent name for those elements were designed. Now, for information that had those 3-letter symbols, please refer to the periodic table that is on page 5 of the lab sheet, so you know specifically what is the current name for that element. So for example, here for the last 2 nonmetals, UUS and UUO, you would do the following. You will go back into the lab sheet, and you will see that those 2 elements are going to be tennessine, which is 117, and then oganesson, which is 118. So for any information that you see at all labs that have that 3-letter code, understand that you need to correlate that to the real name that it is present on the periodic table that I have provided for the lab sheet on page 5. Continuing on, question 3 in this part of the lab asks which metalloid has the highest boiling point. So if I go back into my simulator, all I have to do is click on the metalloids specifically. So to give you an example, I'll start with polonium. You click on polonium and you see that it gives you the information of the atomic number, atomic mass, group number, mass, electron configuration, state of matter, if it's solid, liquid, or gas, the melting point and the boiling point. So to answer question 3 on part 8, which is on page 5 of the lab sheet, you will be clicking all the fuchsia boxes. Okay, so you can see that the boiling point specifically for polonium is going to be 1235 Kelvin. For tellurium is 1261 Kelvin. For antimony, you see that is 1860, and you will proceed clicking on each of the boxes, and then you will record what is the highest temperature that you see for the elements that are considered metalloids. So understand that for the process for answering this portion, it is interactive because you will be clicking on the boxes and answering the questions again, specifically on page 6 and 7 of the lab sheet. Continuing on, the second portion of the lab is going to be the flame test. And for the flame test, you guys are going to be watching several YouTube videos. The first YouTube video is going to be specifically a person demonstrating how to correctly do the flame test. That person is also going to provide the data that identifies the colors for each of the flames and the samples that are given in the video. Then you're going to proceed to watch 3 different videos in which you will see an unknown sample, and based on the data that you collect on the first video on letter A, you will be identifying what are the samples in the unknown 3 videos that you see in the bottom. All of that data is going to be collected, as you can see, in the tables that are on page 9 of your lab sheet. Lastly, you guys are going to be observing some elements. And the elements that you have to record for them their name, their symbol, their atomic number, the atomic mass, which you're going to round to 2 decimal places. You're going to collect the number of protons, neutrons, and electrons for each of them. We have a laboratory display, and that laboratory display is on page 10 of the lab sheet. Understand that you also have to include for each of them if they are metal, non-metal, and metalloids. So when you look at the lab sheet, that element display is right here. You have the elements iron, copper, sulfur, arsenic, iodine, and barium. And all of the data that needs to be collected from this laboratory display is going to be utilized to fill in the information that we have here. As you can see, for each of them, you're going to, in conjunction to the periodic table that we have on page 5, you're going to find the element symbol, was the atomic number, the atomic mass. Remember that you have to round it to 2 decimal places. You're going to find the number of protons, neutrons, and electrons, and you're going to do the classification for them. So for example, the first element that we have here is iron. So I'm going to write the word iron. If I go to the periodic table, which is on page 5, and I find iron, we see that iron specifically is element 26. So I go back to the table that I have. The element iron, the symbol is Fe. The atomic number is 26. And the atomic mass, let me just review to enter the number correctly, is going to be 55.85, because when I round, that's going to be the atomic mass that I need to report. When it comes to the number of protons, neutrons, and electrons. As we talked about it in the background video, the number of protons is going to be the same value that I have for the atomic number, which is 26. The number of electrons, because I'm talking about a ground state element, will also be 26. Now, when I need to find the neutrons, I need to take that atomic mass and I need to round it to a whole number. So I'm going to round that to a whole number. That means that that is 56. I'm going to subtract it from the atomic number, which is 26. That means that the number of neutrons for my iron is going to be 30. Lastly, the classification for this element, because you can see that is in group B and it's the area of the transition metals, this element is going to be classified as a metal. And these are the steps for the experimental procedure in the lab.